Cose's idea was actually to take this one step beyond. And that's the following. Well, these strings are a very low-level representation. And, just cutting a string in the middle to cross over is probably going to muck things up. Right? We are trying to evolve programs, right? At the end of the day, that's what we're trying to do, is evolve programs. So why don't we actually work directly with the programs themselves? And a program is really a tree of, subroutine calls all the way down to simple operations like additions, multiplications, and ands and ors. So let's represent the programs as trees, and then in order to cross over two programs, what we're going to do is we're going to randomly pick a node in each of the trees, and then we're going to swap the subtrees at those nodes. And now we have two child programs, okay? So for example, here, if I do the crossover at this point, then one of the subtrees that I will get is the one that's all in white. And this tree actually represents one of Kepler's laws. This is the law that gives the duration of a planet's year as a function of its average distance from the sun. It's actually a constant times the square root of the cube of the distance, and that's what this is representing. So genetic algorithms can actually discover things like this and much more complex ones as well. Okay? In fact, these days, what the genetic folks are having a lot of fun with is something that's exciting and scary at the same time. They're not just doing this with software anymore. They're not doing it as a simulation inside the computer. They're actually doing out in the physical real world with robots. You literally start with robots that are random piles of parts. And then once those robots are good enough, they actually get printed by a 3D printer. And then they start crawling and walking and doing things in the real world. Right? Seeing how fast they can crawl, trying to recover from injury and so on and so forth. This is actually a real robot from Hod Lipson's lab. Okay? And then what happens is that in each generation, the fittest robots get to program the 3D printer to produce the next generation of robots. Okay? So, so if Terminator comes to pass, this might be how we get there. Okay? Of course, these robots are not yet ready to take over the world, but they've already come remarkably far, right, from the soup of parts that they began with, right? And, in these days, if you see, a little spider running around, take a good look, because it could be one of these instead of one of the biological ones.